Welcome to This Explainer. Today, we're bridging that massive gap between cloning a great starter template and actually deploying a bulletproof production system. Look, we've all been there, right? You clone a repo, it spins up perfectly on localhost, and you feel totally ready to ship. But skipping the crucial hardening steps is exactly how you end up with a server crashing on launch day, or worse, a devastating security breach. It's a journey every serious engineering team has to take, and we're going to explore exactly how to navigate it. So let's dive right in and ask a pretty tough question. Is your template actually production ready? It is so easy to get tricked into a false sense of security just because these templates run beautifully on our local development machines. But while tools like Docker, TypeORM, and OpenAPI are a fantastic starting line, they definitely aren't the finish line. You really can't just hit deploy and hope for the best in the wild. To tackle this, we'll systematically break the transformation down across four critical pillars. First, hardening your security posture. Second, building system reliability. Third, architecture and team rules. And finally, why you should choose monoliths over early microservices. There's a fundamental truth we've got to accept here. A template gives you structure, sure, but a production backend still needs project-specific security, business rules, deployment, monitoring, and operational discipline. Basically, tools alone don't write good code or keep servers running reliably. Your team's shared habits and operational discipline do. Let's kick things off with our first pillar, hardening your security posture. When we talk about authentication, we really have to look way past the basics. In fact, treating a simple JSON web token as your only defense, that's actually an active security risk. Why? Well, standard JWTs are stateless, which makes them notoriously hard to revoke if a user's session ever gets compromised. Real production auth demands features like robust session invalidation, token rotation, and careful device tracking. Your access tokens need to expire quickly, and those refresh tokens must be handled with extreme care. Now, once we've locked down who the user is, the immediate next question is, what are they allowed to do? That is authorization. Basic roles like admin or viewer are fine for a simple toy app, but production systems need precise, policy-based permissions. We have to programmatically control things like, can this specific user refund this specific payment? Or can they view a particular tenant's data? You absolutely need guards at the routing level, but your core handlers must rigidly enforce those exact business rules. Moving beyond permissions, we have to talk about essential audit logs. And notice how these are fundamentally different from your standard application logs. Normal logs tell you a database query ran. Audit logs tell you admin B disabled user C, or user A changed the core product price. These are append-only, tamper-proof records. They're absolute necessities for security investigations, compliance, financial platforms, and IoT systems. They aren't just debug tools for developers. They are official, non-repudiable business records. To wrap up our security defenses, you've got to defend your expensive endpoints. Logins and password resets require heavy cryptographic work, like password hashing, that can easily spike your CPU. Prime targets for abuse like these must be protected. You need to implement strict rate limiting using tools like Redis, API gateman rules, or framework throttlers. You want to stop brute force attacks and spam requests dead in their tracks before they can even touch your underlying infrastructure. Moving right along, let's look at our second pillar, building system reliability. If you're deploying to an environment like Kubernetes, simply returning a generic status OK from a health endpoint is incredibly weak. You actually need three distinct checks. Liveness checks if the process is breathing, readiness checks if it can successfully take traffic, and startup checks verify if it's completely finished booting. For example, if your readiness check fails because the database connection drops for a second, the load balancer knows to temporarily stop sending traffic to that specific instance. Getting these three right is absolutely mandatory. Next up is your CI/CD pipeline. Look, relying on manual deployment is just way too risky over time. Building a rigid automated progression, lint, test, build, scan, deploy, ensures that bad code physically cannot reach production. If a test fails, the pipeline stops. During the scan phase, if a tool flags a newly vulnerable NPM package, it stops. The application should literally not deploy if any of these safety checks fail. Then we have database discipline. Database mistakes are incredibly expensive and notoriously hard to walk back. Enforcing operational rules like migration review checklists, defined rollback plans, and slow query monitoring is absolutely critical. We also need advanced strategies like the outbox pattern for events. This guarantees your system only sends a message to a queue if the underlying database transaction actually succeeds. This level of discipline is what truly prevents a single bad migration from taking down your entire production cluster. And when it comes to system reliability, remember this golden rule. Never block an HTTP request for heavy work. Just imagine a user waiting 10 agonizing seconds for a web page to load just because your server is busy talking to a slow SMTP server to send a welcome email. It's a terrible experience. If you're sending emails, generating complex reports, or processing webhooks, you have to offload those to background messaging systems like BullMQ, Kafka, or RabbitMQ. Return a fast, snappy response to the user and let the background worker handle the heavy lifting. This naturally brings us to our third pillar, architecture and team rules. Without internal rules, even the best architecture slowly degrades into chaos. First off, you need to standardize your APIs. A predictable API uses consistent JSON structures for single items and paginated lists. For errors, you should adopt a widely accepted industry standard like problem details. But the real game changer here is the universal trace ID. By dropping a trace ID in every single request and response, your front-end, back-end, and observability tools can perfectly connect the dots from start to finish. It makes debugging distributed requests an absolute breeze. Now let's talk about the Trojan horse danger of the shared folder. It is so easy to treat this folder like a junk drawer. Good shared code is entirely generic, things like pagination logic, base error classes, or authentication decorators. Bad shared code is anything containing hidden business logic, like a product helper or a common business service. Developers love dumping random code in shared folders because it feels convenient, but it creates deep, hidden coupling. Only truly reusable generic components belong there. The rest needs to live securely inside its specific vertical slice. Finally, let's tackle our fourth pillar, monoliths over early microservices. This is easily the most common architectural trap teams fall into today. When you jump into microservices prematurely, you hit a sheer wall of technical debt. Suddenly, you're managing network failures, distributed tracing, complex data consistency, service discovery, strict event versioning. The list just goes on. This harsh reality completely overwhelms any argument for adopting microservices just because they sound modern or exciting. They add massive operational complexity. Jump in too early before you fully understand your business domain, and you're going to spend all your time managing infrastructure overhead instead of actually shipping features for your users. And that brings us to a foundational piece of advice. Start with a modular monolith. Make those module boundaries exceptionally clean, and split them out later only when there is real scaling or team pressure to do so. A good vertical slice architecture is perfectly designed for modular monolith. It gives you a single deployable backend, which is incredibly easy to host and manage, without sacrificing strict internal boundaries. Because the boundaries are clean, splitting them into microservices later, if you ever actually need to, becomes a straightforward refactor, rather than a complete, messy rewrite. Which brings us to our final takeaway. A template cannot save a team from bad engineering habits. The tools are there, the starting line is drawn, but crossing the finish line requires true discipline. So, with all this structure laid out across security, reliability, and architecture, what operational discipline will your team adopt today? How will you ensure your next big project doesn't just launch, but survives and thrives in the open ocean of production? Think about that as you look at your code base tomorrow.